Welcome to Omron's SIP Safety Solutions video series. In this video, I will be discussing how Omron can help solve the challenge of reducing machine commissioning time using integrated safety solutions. Let's talk about implementing a robot application where a safety solution must meet functional safety requirements to be compliant with safety standards and local regulations like OSHA. Depending on the process, this could mean using more safety devices or a more advanced architecture, which could increase the amount of time required for development and implementation. Our solution can solve this type of challenge by using several of the built-in programming features in Sysmac Studio. These include a drag and drop process for quickly adding and configuring safety devices, automatic programming, and simple automatic test. All of these features can help shorten the design cycle and startup time. Let's switch over to Sysmax Studio to demonstrate these features. Sysmax Studio is the integrated development environment used to create the safety program. It is a true integrated development environment because it can be used to program the controls, vision, motion, HMI, and safety. The safety hardware can be set up easily using the built-in drag and drop features of the software. Let me show you just how easy it is to add and configure devices to Safety I/O. I currently have a safety program started and need to add some safety devices to my Safety I/O cards. In the Multi-View Explorer window, I have selected the target safety CPU that I want to configure. Next, I will navigate to the specific Safety I/O card and select Parameters. After selecting the parameters for the specific card, the Parameters tab page will appear. It shows the NX Bus Master, the NX Unit Configuration window with all the connected units, the Parameter Setting window, and the toolbox that includes the library of devices that I will be adding to the card. I'll need to add an e-stop to my input card. All I need to do is select the e-stop from the toolbox and drag it to the desired inputs of the card to connect it. Once the device is connected, I can right-click on the device and edit the detail settings, including the on-off delay time, discrepancy time, as well as change the device and contact icon if available. I can also add a description of the device in the comment field next to the input. This comment will appear in the I/O map and will make it easier when adding variables. After I finish adding the devices to this card, I can select the other I/O cards by either selecting the module from the rack shown above or by selecting the parameters in the Multi-View Explorer window. The next feature in Sysmac Studio that I'd like to demonstrate is automatic programming. This feature allows you to import your variables, set up a truth table, then generate the safety program automatically. Automatic programming allows you to spend your time to focus on how your system should behave and not focus on the details of the function blocks for the program. For instance, let's say an e-stop or a safety gate switch in Zone 2 trips. All you need to think about is how should each of your safety outputs respond, so it turns all of your safety programming into just generating truth tables. So let's take a look at one of the sections for the safety demo that includes the NX CSG320, NX SL5500, 2 safety input cards, and 2 safety output cards, with an e-stop, reset push button, safety gate switch, and safety relays to demonstrate how to automatically generate a program. The real benefit for this feature would be on a larger system with multiple input and output safety devices. After setting up the hardware and assigning the variables, open up the automatic programming window by navigating to the Programs section in the Multi-View Explorer window. Then right-click on the programs and select Automatic Programming. First, you need to add the reset input, then add your input variables. In my case, I will add an e-stop and gate switch, and then safety relays for the output variables. You also need to add function block name for the input variables. If you have a large number of variables, you could also just select register variables to bring in all of them at once. The next thing you need to do is fill out the expected value settings and set the output value for each input condition. If you have multiple zones with several input and output devices, you would configure each of the devices according to their behavior for the specific zones. Once the table is completed, you press Generate to create the program. Sysmax Studio will generate the safety program automatically. When you open the program, you will see that a special reset function block is created at the top, and then there are the function blocks for each of the safety input devices. The eStop button has an eStop function block, and the safety gate switch has another eStop function block. Scrolling down further is the logic for the safety outputs based on the truth table. And then lastly, I have the EDM function blocks for the output relays. The only thing I need to do for the EDM signals is just assign the right EDM input to the EDM function block. With that, the main structure of my safety program is done. So from here, I can add the final details, download my program, and run the simple automatic test to check the program. In this video, I have discussed how Omron can help solve the challenge of reducing machine commissioning time using integrated safety solutions. For more information on Omron's SIP safety solutions, please visit our website at automation.omron.com. Thank you for taking the time to watch this video, and I hope it was helpful.